we're going to see if we can get an understanding of division of fractions.
How can you model division of fractions? Think about this question during the lesson.
What we're seeing here is a shelf, and underneath it is a yardstick. This might be a good time to remind you that there are 3 feet in 1 yard. Once again, there are 3 feet in 1 yard.
Mr. Roberts uses pieces of wood that are 3/4 foot long for a set of shelves he is making. How many pieces of wood can he get from a board that is 3 feet long? Let's find out.
So what we're actually saying is, how can you divide 3 by 3/4? 3 feet divided by 3/4 of a foot equals what? That's our question. Think about that. 3 divided by 3/4 equals what?
Think, how many 3/4 are in 3?
Let's take a look at that. Well, there are 4/4 in 1. There are 8/4 in 2. And there are 12/4 in 3. So how many 3/4 are there? There are 12 1/4. There are 12 1/4 in 3 feet. 12 times, and remember we can write this as a fraction over 1. 12 divided by 1 equals 12. 12 times 1 equals, I'll write this in blue since we already have an answer here, equals 12. 1 times 4 equals, so 12 divided by 4 equals 3 feet. So let's continue on with the lesson and see what we can find out.
Use the number line to show 3 feet.
So we're showing 3 feet here, and each of those feet is broken into 1, 2, 3, 4 parts.
Why use the number line with 3 units that are divided into fourths?
Well, we have 3 units. Why? Well, we have a yardstick, and a yard has 3 feet. And we're breaking it into fourths because our fraction is 3/4.
The number line represents the 3-foot board, which will be divided into 3/4 foot sections. How do you divide the number line into 3/4 foot sections?
So these are broken into 1/4. How would we break that into 3/4?
You measure each section on the number line by counting 3/4 foot for each piece. How many 3/4 foot pieces are there in 3 feet?
Remember that here in this one piece, it's broken up into 1, 2, 3, 4. 4 parts. So one of those is equal to 1/4. So 1/4, 2/4, 3/4. So this red oval is 3/4. This is 3/4. This is 3/4. And this is 3/4. So we've taken 3 and we've divided by 3/4, and that is going to equal how many? I'll let you answer that for yourself.
There are 4 3/4 foot pieces in the 3-foot board.
1, 2, 3, 4. So 3 divided by 3/4 equals 4. Let's take a look at our algorithm of skip, flip, and multiply. Remember, we can write 3 as a fraction. 3 divided by 1 equals 3. And then we're going to skip, flip, and multiply. 4, we're going to skip, flip, and multiply. We're skipping this. We're doing the multiplicative inverse by flipping 3/4 into 4/3. Then we're going to multiply. So 3 times 4 equals 12. And 1 times 3 equals 3. And 12 divided by 3 equals 4. Why did I divide? Because I have an improper fraction. To convert an improper fraction to a proper fraction, I divide. 12 divided by 3. And I can do that because all fractions are division problems. So our answer is 4.
Compare the quotient to the dividend.
Quotient is an answer. We have a dividend and a divisor. 4 is bigger than 3. How do you take a number like 3, divide it by something, and get 4?
When the divisor is less than 1, the quotient is larger than the dividend.
So you can expect larger answers when you are dividing by less than 1.
Another way to solve this is to think of division as repeated subtraction. First, rewrite 3 as an improper fraction. 3 over 1 times 4/4 equals 12/4.
This 3 divided by 1 equals 4. We're going to multiply by a magic 1. And we're going to get 12/4 because we need to have this in fourths. So this equals 3 and this equals 3. Because 12 divided by 4 equals 3 and 3 divided by 1 equals 3.
Why do you multiply 3 over 1 by 4/4? You multiply 3 over 1 by 4/4 to convert the whole number into fourths, because changing the whole number into fourths makes it easier to subtract the fraction. Why do you rewrite 3 as 12/4? By rewriting 3 as 12/4, you make a fraction with a common denominator that is easier to subtract. Now subtract 3/4. What is the result? Repeat the subtraction. Repeat the subtraction. Subtract one more time. Mr. Roberts can cut 4 pieces of wood from a 3-foot board. Now you know how to model the division of fractions.
So let's take a look at some problems. It says write the division sentence represented by the picture. Well, we have 4 holes, and each one of those holes is broken up into 1, 2, 3 parts. So we know our denominator is going to be 3. And let's see, we have 4 holes, so 4 divided by, and there are 2 parts in each of these. So 4, sorry, I should have written that correctly. 4 divided by 2/3. 4 divided by 2/3 equals 1, 2, 3, 4, 5, 6 equals 6. Let's try that with our algorithm of skip, flip, and multiply. We'll rewrite 4 as a fraction. 4 divided by 1 equals 4. We're going to multiply the multiplicative inverse, 2/3. We're going to make that 3/2. 4 times 3 equals 12. 1 times 2 equals 2. And 12 divided by 2 equals 6. And it says write the division sentence represented by the picture. Let's take a look at this. This is broken up into 1, 2, 3, 4, 5, 6, 7, 8 pieces. And so let's see, we have 8 is our denominator. That's our whole, 8 pieces. 1, 2, 3, 4, 5, 6 of them are shaded in. Let's see, what did they divide that by? They divided that by 1, 2, 3 of those 8 pieces. So 6/8 divided by 3/8 equals 6 divided by 3 equals 2. We're not supposed to do that. That's why we do our algorithm. Skip, flip, and multiply. 6/8 times 8/3. 6 times 8 equals 48. 8 times 3 equals 24. And 48 divided by 24 equals 2. And that makes sense because there are 2 equal parts, 3/8, 2 equal parts of 3/8 in this 6/8 of a piece.